All right, if we need to sketch the function out, first example, we're going to let f of x equal x squared plus 4. And we're going to have a restricted domain here. Restricted domain for what the x's can be on this function will go from -1 to 2. And that is inclusive. All right, a whole lot of strategies come to mind here just to get started in sketching this function out. And we're supposed to be familiar with certain types of curves. We're supposed to recognize that x squared, that's a quadratic. So this is going to be a parabola that we're dealing with. In fact, ignoring the restrictions for a moment, if I just sketched out f of x equals x squared plus 4, I would start with the understanding that x squared passes through the origin, right? It kind of forms a curve like so. But this transformation with that plus 4 is going to move that key point at the origin up 4 places. And x squared plus 4 as a function would look something like this. Now the thing is, we do have a restriction here, so we don't want that entire curve. We only want a portion of it. So to figure out, the key points basically on this curve where we want to kind of cut this into pieces, we could take these x values, we could plug into the function. If we plug in our x's, we'll get our corresponding y's. We could plot those points on the curve and then kind of section off what we need. So if you take -1 and I insert back in the function up here, got -1 squared plus 4. If I get that all calculated out, that'd be 5, right? I know one of my key points will be right here at -1, 5. So if I highlight that point in the graph, knowing that it's going to be included because of the bracket, there's that point, right? Other key point, if I take 2 and plug in, it's going to be 2 squared plus 4. So that's going to be 8. If I highlight that key point on the graph, again included because of the brackets, there's that guy. If we want everything between -1 and 2, that's everything right in here. Well, to highlight what I actually need, just shade this in. And we could understand looking at this that, okay, the blue section there, that's our graph. That's our graph of this function on this domain. If you want to go in and take out these other pieces, you can do that. But as long as the key parts are highlighted, we get the idea, right? All right, we'll try another one here with some restrictions. This time we're going to let f of x equal 5 minus x all over 5. Restriction on this one be 0, not included, up to 10, which is included. Now, as you look at this function, again, we're supposed to recognize, just in looking at these functions, what kind of graph we have to deal with in the first place. What kind of function is that? Anybody know? What if I divided this 5 through? As long as I divide the 5 to each term in the numerator, so 5 divided by 5, 1, minus the 1/5 x. As long as I'm dividing that through to each term, it's okay, right? Now, any guesses on what kind of function this is? Come on, it's a line, right? It's basically slope-intercept form. Put my x term first, got your y-intercept second. So we could graph that line. We could have a y-intercept of 1, go down 1, 5 to the right, correct? Get our 2 points. Or if we know that finding key points because of the domain restriction is useful, just need 2 points to determine the line, let's go ahead and take these values from the domain restriction, plug into the function. So plug in 0, and plug in 10. We'll get those two key points, we'll plot those out, we'll draw our line. We'll draw our line in between those two. So plugging in 0 to start, I go down to the simplified form here. It actually doesn't matter, you can go back to the top as well. If I go to the simplified form, I plug in 0, this is going to go to 0, right? And all that's going to be left is 1, which should make sense because the y-intercept is going to be 1. That's when x equals 0. Plot that point out, understand that 0 is not included, right? So when I plot that, it's got to be an open circle. Now, for where x is 10, we plug 10 in. Again, doesn't matter if I plug in here, if I plug in up here. It might actually be easier to plug into the original function form. It'd be 5 minus 10, so negative 5 over 5, that'd be negative 1. When x is 10, y is negative 1. If I plot that point out, it's going to be over here, and that's going to be included, right? We want everything between those 2 points. So connect those 2 points. Got my little line segment. So with a piecewise defined function, we've got 2 pieces to analyze here. If I start with this first piece, basically I'm looking to see what the graph of y equals 2x plus 1 looks like. And then if I look at this second piece, I'm looking to see what the graph of y equals the square root of x minus 1 looks like. Taking it one piece at a time and transferring it over here. Y equals 2x plus 1, we know that's linear. So we're going to have a y-intercept at 1 and a slope of 2. However, we also know that we only want the graph of that line when everything is less than negative 1, right? So if I throw a couple of key points in here just to start with, y equals 2x plus 1. I mentioned the y-intercept being at 1, and then the slope, we go up 2 over 1, right? So right now I know I've got a line going through basically these points right here. But if I throw in the x is less than negative 1, let's plug that in. Let's plug in negative 1. If I plug in negative 1 to that function, I've got 2 times negative 1 plus 1. So f of negative 1 is going to be negative 1, right? So maybe another key point to plot here would be at negative 1, negative 1. So that's going to be down here. Now, is that going to be an included point or not? Since it's just less than, it's going to be open, right? We know essentially the line's going through here, but everything that is less than negative 1, well, let's see, on the x-axis, this is negative 1, less than is going to be over here, right? So we want the portion of the line that kind of corresponds to all these values. We're going to take the line down here. Right? That's everything that is less than negative 1. Now, for the other graph, y equals the square root of x minus 1. If you think about a graph for the square root of x, think about a radical graph. You basically got this curve at the origin here that kind of comes out this direction, right? What's this minus 1 do to this graph? Which direction does it move? It goes 1 to the right. Right? If it's underneath this root, if it's contained within the symbols, it's moving horizontally. So if we subtract, we're moving that distance to the right. In this case, that distance is 1. So normally I'd be starting here at the origin. I'll move that point 1 to the right, and then that will be an included point if you look at the restriction, right? It's greater than or equal to 1. And if I just sketch out that curve after it's moved out this direction, all of that is greater than or equal to 1, right? On the x-axis, if this is 1, these are all the values where it's greater than 1. So all these points correspond back down to the axis. There's your piecewise defined function.